Welcome to a small edition of the KQL Cafe. It's a month where I think everyone is pretty busy. So let's begin. So today Alex is in Ireland for holiday. So we'll do without him. And we've also shortened the sessions for today a bit, because IOCs weren't any nice ones to share, and also the KQL tools is something that Alex usually presents. So we'll do that one the next time when Alex is back. And also we have today's guest is Mehmet Ergene. And Mehmet, would you like to tell us the guest something about yourself?
Yeah, hi everyone. My name is Mehmet Ergene. I'm a threat researcher at the moment. I'm working for a DFIR company. We are developing a product. But I will go into details during the presentation.
Cool.
And thanks for the invitation, Gianni.
It's love to have you, and also really looking forward to your presentation next. So, what's new this month in KQL is you have now the Defender Vulnerability Management Suite, and the Defender Vulnerability Management Suite has several components. It has the security baseline assessments, inventories, network share analysis, blocking of vulnerable applications, vulnerability assessments, and also consolidated asset inventories. And the new tables for this month are the ones regarding the baselines and the configuration assessment and the certificate info and browser extensions. And you can use that to make sure that you can play with the data. So over here, in the left pane, you have all the new tables. And the idea is that you can query them and also make easy assessments about the configuration of your devices without having to go to the browser, to the GUI. And you can also use these queries to make your assessments better, and also you can automate reports with PowerShell or with Power BI or with the Jupyter notebooks. So that's really nice. And over here you also have the compliance assessment. I've enabled this feature yesterday, so I hope we have some data. Not yet. But what we can do is we can look into the KB side to see which data there should be in there. Because what they did is they have all the benchmarks, all the audit items. And over here you can see what the items are and in which profiles they are, and what the recommended value should be. So once you have the data in your table, you can query it, but unfortunately my tables didn't load that fast. And also in the security, the TVM certificate info, you can query your systems for certificates. So if you have a certificate for MPS or for some other authentication mechanism in your network and you want to make sure that the lifetime is still okay, you can query that from here. So for instance, if we want to know if the expiration date, so where expiration date is less than now. And we have all the expired certificates on this specific system. And you can easily check if there's anything else. And you can also quickly check if there's anything special, or if there may be malicious certificates on the system, or everything that's related to certificates. And there's also the configuration assessments. And that one is based on the profiles. This is the, I guess this is the old one. So these are all the recommendations from the old TVM. With the new tables, you can play around with the data. And then we already introduced Mehmet.
Oh, that was quick.
Yeah, I think I mixed up some of the slides. So if you want, and if not, I'll get to the next slides, and then you can get back.
Yeah, no problem. Hello, everyone. Let me share my screen then. That's okay. So today, I think last month, Olaf talked about a little bit about scan operator. So I will talk about it in a bit more detail. My name is Mehmet Ergene. I'm a senior threat researcher at Binalyze. Binalyze is a DFIR company. We are developing products for enterprise forensics and instant response in general. I'm a Handpan player, Lindy Hopper, and also a Microsoft MVP. Handpan is the instrument that you see in the right corner, because most people don't know what a handpan is, so I wanted to at least introduce it. On Twitter, I'm Cybermonk, and on GitHub, I have some repositories, especially related to KQL and queries for threat hunting and detection, so you can check that out. First, I will talk about process mining, and then I will explain how scan operator in Kusto works, and also give a demo to show its capabilities. So in general, process mining is a integral part of the data science. And what it does is it's usually, in general, it supports the analysis of the operational processes based on the logs. So by operational process, I mean, like you can think of anything related to anything operational, like user behaviors or car manufacturing, etc. And with process mining, you can identify executional paths, and it has, in general, most of the time, two components. One is the process instance, and the second is the process model. So process instance is a user or device or a session or anything you can think of. And the model is the steps that you define in your process. For example, if we think about an online web shop, a user logs into a web shop or online shopping website, and then browses some products, and then adds some of them to the cart, and then checks out, and then pays, and then logs out from that site. So from this is a process in terms of making an order or buying something from an online web shop. And with process mining, companies try to improve the user experience and also try to improve this process in terms of for example, the time that you spend on the web shop, the online shop. So if you have, for example, issues by when adding something to the cart, then they want to see where the problem is and then try to improve it. And this process mining, since it's based on a process and then executional path, let's say, you can also use the same method for threat hunting or threat detection or user analytics or user behavior analytics. As a sample scenario, so when a user downloads a zip file and then opens it, and then this is a well-known attack nowadays, there is an LNK file, a shortcut file, and user executes it. The executes or opens the LNK file, and then LNK file runs a PowerShell command, and then PowerShell command downloads a C2 beacon, and then C2 beacon starts communicating. So if you look at everything in an order, this is a process as well. So there's an interaction, and it goes one by one. So in Custo, we have a new operator, which is still in preview. So the scan operator, I don't know why it's still in preview, because it's been a while. It's been released, but I think they are still trying to observe if there are any issues, because I saw some issues on the tech community, which was fixed. I think, yeah, that's why the computational or the computations with this scan operator is a bit complex, and probably they want to test it properly to make it generally available. But in any ways, it works for the time being, at least for our purposes. So the scan operator basically performs process mining, and it can perform user analytics or recursive calculations. Like recursive calculations, I mean, you are, let's say, summing a set of integers or numbers in an order. So in order to use scan operator, you need to define a process model first, and which is the attack execution in our case, or the web shop, the online web shop experience, and you need to feed that model to the logs. And for threat detection, how we can define a process model then? So you can basically just simulate or execute attacks and then analyze the logs in an order to see what is happening during that attack execution, and then find the relevant logs and relevant events, and then create your process model based on that. And this is a scenario that I have executed in the past. It's a bit blurry, the image, sorry. I will also show the events related to this one. But here I have executed KRB relay tool, which performs Kerberos relaying. So in this attack, this is an ordered list. So first, this tool, this is the KRB relay.exe. It performs a connection to domain controller, and then performs the LDAP queries, but I didn't include them, and I think I also didn't so when I execute the attack. And then it creates an listening connection on the host. After that, there's a name pipe event related to probably this catalog listener. And then again, the same port is being opened with the IP version 6, and there's a connection to the RPCSS, RPC server. And after that, there are some events, and there's a connection here by a DCOM object to the port on the host that was just opened here. So by looking at the logs, we can create a process related to specific attack. Now I will show how it works and how we can see the events. I think it was here. Let me see. So I have executed this attack 2 weeks ago, if I remember correctly, and I just filtered the relevant events to show. So this is ordered by timestamp in an ascending order. So the same Kerberos relaying attack here. You can see the KRB relay tool. So first, I should start here. There's a connection, and then listening connection creations, one for IP version 4, one for IP version 6, and a named pipe event, and then inbound connection to the port that was just opened here. So again, there's another connection success on IP version 6. And lastly, the same event related to this event. Like since the port is opened on the same host, so you have one connection success. So you are connecting to the local host. So that's why you have connection success and also inbound connection accepted event. Now let me see. Before going into details related to that, I will show some simple stuff. So the scan operator, let's say you have such events happening in an order. So you are ordering it based on the time span. So event A start and B D stop. So these are the events. And if you have a model or if you want to see what is happening between a start and the stop event, because as I said, you need to define a process, and to do that, you need to have a starting point and an ending point. So in this case, we have start and stop as a starting event and or the process start and the process stop. And if we want to find what is happening between these two events, because this is let's say a single session, and we don't know what is happening exactly, and we are trying to see, or we are trying to figure out. So what we can do is, so the scan operator first runs on an ordered events. So you need to order events by timestamp or time span in an ordered day. And then you can run the operator. It has some parameters. So basically, in general, so the simplest way of using it is scan and read, and then you need to define your steps. Steps are the here. The steps are the stages that you define. So, for example, you need to define this downloading a zip file as a step, and then extracting a zip file as a step. By using match ID, we are basically saying that we need to tag the matching events. I think it should be better here because this is quite simple, but anyways. So here I want to see all the events between a start and stop. So to do that, first, my first step is the start event. So I'm defining the step here, and this is the first step. And then I'm providing the condition for that step. So for each step you have conditions, and also you can have some output parameters. I defined the first step as a start, and then the second step can be anything except the stop event and except the start event, because I want to find the events between start and stop. And I'm putting another condition here. I'm saying that everything should be happened in 5 minutes. So after the start event occurs, or after something starts, then in 5 minutes give me everything. And so here we defined the second step and defined the condition. I think this part is the most powerful part of the operator, because you can correlate events together here. So I have an event here which I defined as S1. So in the second step, I can say there should be a 5 minutes of difference maximum between this first step and the second step. Otherwise, it will not match the events when analyzing the query, analyzing the logs. And then in the third step, so I'm saying that this is the last step, and it should be the stop. And then again, the difference should be less than 5 minutes. And these were the raw events, the whole table. But when I run this, I will get let me session ID, which is more understandable, I think. So here we have the first event and then the session ID. So when the operator finds matching events, it tags with the session ID because of this condition, and it shows which session it is. So in the first session, which is the with the 0 ID, we have start event, and then B and D events, and then stop event. And then it finds another session here. The session ID is 1, and in this session we have start and the event E and stop. That's all. And here we have only one start event. So although I said we want to see the events between start and stop, the output shows all the matching events. So this means that if you want to see only the whole session where start and stop event occurred here, so you cannot do that because the operator, this is the way how this operator works. It starts matching events from the last step, and then starts going up to the first stage or first step. And basically that's why you see here, although you said you have 3 conditions or 3 steps, but for the second session with the session with the ID2, you have only one event, because it only matches this one, but there is no match here. And what you can also do is, in this part, you can do some calculations, or you can add new columns. So let me show you this. So in the main table, I have only two columns, the TS and the event. But if I want to add a new column and add some data in it, then I need to do it here. Matching ID. I need to declare what was that? Let's say new column name and the type of the column. And when I do this, I can use this new column inside these steps or inside this function body, let's say. And how I can do calculations with that. So if I don't do anything, then by default it will be null, if I remember correctly. Let's see. Yes, it will be empty. And if you want to add some additional information, this is how you can do. The arrow sign with the equal sign, and then you provide the new column equals. You can add a string here. Let's say this is step 2. And when you do this, when it shows, when it finds a match, it will extend the column and put this information. You can also make some extra calculations, like get an information from step 1 and then add it to the column itself. And when you don't do it, when you don't use this new column or this new definition method, then you will see the empty columns for that, or empty fields. What else I can say before going to Kerberos relaying? Let me see. I talked about that, yeah. Okay. Now, if we go back to the Kerberos relaying events, so I ran the tool to simulate the attack, and everything happened almost in a second, or almost in a second, I think here. So I can use this information while defining my steps. And let me go this part. These are the time fields that's just for the execution that I performed, so that I can find the logs. So as I said, it will record all the inputs against all the steps, starting from last step here and to the first. But first, I need different events here, because I have connection events and name pipe event, which is in the device event table, and these are also in the device network connection events. So I'm just getting the relevant data here, but just by I'm just filtering the relevant data. It's because when you run this operation or this operator on a huge amount of data, and if you have complex steps, then you might have performance issues or some resource limitations. I'm just extending the pipeline just to use for this example. And here I'm sorting the timestamp, and then the scan operator starts. So I used funnel ID, for example, here. You can use anything you like. So whenever there is a match with the session, so I will see which session it was. And I'm declaring a step just to see which event corresponds to which step in the output. We have here another operator, which I will show in a bit. Equals none. So my first step is you can give any name you like. So I'm defining step with the actions or the steps or the stages in the execution path. So connection to DC and connection success. And I'm extending a new column as I declared here. And I'm saying that this is the step 1. And same for listening connection creation. And here what I'm doing is, so I executed the attack on a host. So I need to find, or I need to match the events on the same host. And to do that, I need to correlate these events together. And how I can do this correlation, here I have the connection to connect to DC step, which is the step name. So here I'm saying that in the condition, the device ID of this event in this step must be equal to device ID in this step. So this way I'm matching the relevant events or the exact the required events from the same host. And then the action type and file name, these are relevant to the events itself. And here, for example, initiating process file name. So since I saw that the process is related to the same process is executing some of the actions. So I'm saying that the process file name again must be equal to the initiating process file name of the previous step. So this was the previous step. So again, they should be equal. And the reason why I'm doing is that you can have other events happening or other stuff happening on the host. And if you don't match it properly, then you might have false positive, or you might see different events, which we will see in a bit. So I'm providing how to say, I'm increasing the precision of the matching algorithm of the session. And then last, again, the process ID should be equal so that I don't have a false positive matching. And I'm giving the name into the step column as a S2. And same stuff here for the name pipe event. Again, these are the conditions based on the execution. And connection success, again, same stuff. Device ID should be equal to the device ID of this event. But you can also, for example, say device ID should be equal to the device ID of this step. So it doesn't have to be the first step. So you can correlate steps any way you like. And I think I'm doing it here. For example, in the connection success event, I have listening connection created step here. So in the connection success, I'm saying that the connection event the port of the local port of that connection event should be equal to the listening connection created steps port. So that way I'm again reducing the false positive options. And I have a timestamp condition here, or time spent condition. I'm saying that this should happen in 15 seconds. So I thought, although the process or the execution that I did is happened in just a second, but as an attacker, you can just delay some of the executions and then execute the attack. That's why I just increased. And again, here I'm adding the step name. And last item, the inbound connection accepted. And here same conditions and same correlations from the previous steps. Connect to DC and listening connection creation step. So local port of listening connection creation step. And I'm just changing the timestamp to this format and then reordering the columns. So let's see.
There's also a question in the chat.
Yes.
It's the events of different devices should be processed separately, right? If not, maybe two start events happen in the device.
It totally depends on how you define the process. For example, you can also say, I don't know, let's say you are trying to find potential worm activity or ransomware that is spreading through your devices. Then in that case, you should see same executable, let's say, same executable being copied to different devices in 10 minutes or in a half an hour. So you can say then that is the file creation event, and I can order all the file creations. And if a file is being created, let's say in 100 machines in 10 minutes or 30 minutes, then you can also create such an alerting mechanism. So it doesn't have to be the same device ID. It's totally dependent on your on your use case. But in this case, the attack happens or the execution must happen on the same host. That's why I'm saying that all the steps should happen on the same device. Otherwise, since I will have lots of devices onboarded and I will have a huge amount of data, so it will match anything without the device ID. So you can have one event from device ID X and another event from device ID Y, etc., etc. Does that answer the question?
Yes, it did.
Okay. So here I added a new conditional parameter, output none. So when you run the scan operator, it outputs or it shows all the events that matches all the steps. Now what I mean is that if I remove this parameter, so here I'm providing only one condition to connection to DC or connection on this port. it's just one step or one condition, one matching event in general here in the executed attack. But now we will see something different here. Now, as a first step, let me show you this remote port and local IP, file name. Yeah, this should be more visible. So when there are several events matching to one step condition, then this operator shows all those events, not only one event. You can change that behavior. Come on. I have only 5 devices. So here, these three events match the same condition because I'm also extending or creating a new column and defining which step it was. So the first step, S1, I have 3 events, and it's just because it found a match for this condition. And you can change this behavior if you don't want to see, for example, all 3 events. You have 3 options, if I remember correctly. You can say output all. This is the default, so it shows all the events that match the condition. And then you can say, I think last. It shows only the last event, so only you see only one event. And then if you say none, it doesn't show that event in the results. Now we should see, I think 4 in total, or 5. So now I don't have any of the events from the step 1 because I omitted all of them. So I have only 1, 2, 3, 4 events. And another important thing related to scan operator when it runs. So you say you define a process or the execution path of an attack, and the user must download this file and then execute it, and then connection must happen. Even if you define this process in these steps, when the operator runs, it starts matching events from the last step. And if there is no matching event on the last step, then it goes one above and it checks this one, and then it checks the other one, and then it goes to the first condition. And because of this logic, I think even if you say the execution path or the process must end with a specific condition or specific event, in this case, I have this event. So this is the last event of this execution. Even if there is there isn't any event matching this condition, it can show these 4 events if there is a match. So this means that when you define your process or when you define your steps, you need to be careful, because if there are 2 events that match only these 2 conditions, you will get a result. It will show only those 2 events. And if I think I can show it here. So I'm removing this part. Yeah, this should be correct. No. So here I'm changing. I already did it. Okay. So this is the normal one. I forgot to remove. We will have this inbound connection as the last event in a normal session. Yesterday it was faster than today. I don't know if they are changing anything.
I guess you ran out of coins.
So here I have the last step as step 5. So now I have I omitted the results here in the conditions. So I said do not show this event, and I have as step 2, step 3 event, step 4 event, and step 5 event. Now let's say I'm looking for something else here, just a random action type. It doesn't matter. So the event will not match to this step, especially this S5. And when I run this query again, even if there is no match for the last step, it will show me the matches of the first 4 steps. So I don't have the last step here, even if I'm looking for a specific event and there is no match, but still I'm getting some results because there are matches for the first 4 steps. And this is important because when you want to detect something, especially such execution path, then you need to filter results properly. And how you can do it is quite easy. You can just filter, let's say, so I added a new column here, step S5. So I know that this is the last step. And if I say here where step equals S5, then it means it will show me only the S5. But of course, if there's an S5 event. Yep. Now I'm filtering, or here I'm just saying that I want to see completed sessions or completed executions. So if there is, for example, in a general case, if there's only a download event and there is no execution, then you can say, okay, I don't want to see if there is no execution related to that file, or I don't want to see the execution if there is no connection. So I'm not seeing anything because there is no match in the last step, and this way I can make a detection rule with this query. So now there will be a match because this was the correct condition. So I'm just saying that if there is a match at the last step, then it means the attack is completed or executed based on these 5 steps that I defined. And it will show me only the last event. And I can just turn this into a detection rule. And if I don't do this, I don't filter and just create a detection rule, then as I said, there will be events matching only first 2 or first 3, then you will get false positives. So here I have only one event, then I can say, okay, there was an execution path which was completely finished with the last step, and just create an alert for that. What else I can say about scan operator? I think, yeah, this is the real power. You cannot, when you create a detection rule, it's not wise to it's not wise not to use this filtering, because you will get lots of false positives and you will get one alert matching with lots of events. And if you want to see all the steps, then you can just set your query timestamps like this one, and then just run the query and check the all steps that are completed. So at the moment, I couldn't find a proper way. Let's say you created a detection rule using this operator, and then you want to see all the events happened based on these steps, and there is no easy way to get all the events of a completed session or completed execution path. That is the only difficulty. I think, yeah, maybe you can do it by using let commands and then caching results and then doing the same calculation. I don't know. I didn't try it yet, but it might be one way of doing it. But yeah, at least even with this method, you can say, okay, I want to create an alert, or I want to detect a scenario. And this is the power of the scan operator, in fact, because when you try to detect something, you start creating certain conditions that contains only one stage or one step of an attack. And let's say, for example, yeah, I want to detect schedule task command on the command line, but it's also used legitimately, and you start getting false positives. But when you say when you add additional steps to that attack and then define in this way, then you can also solve these false positive issues. You can say, for example, if there is something happened and then there should be another event happened, like if there's a file or DLL dropped, then it should be run by, for example, run DLL32 or some process. So you can combine these events together and then create like higher fidelity alerts, I can say. So that's why I see it as quite powerful. And yeah, I think this is all I can say about this amazing operator. If there are any questions, I can answer.
I think I do have a question, because would it be possible to use the scan operator to detect a successful brute force attempt?
Yes, you can do that. And especially related to brute force attack, what I have usually seen is that many of the queries related to brute force only checks failed attempts. But the problem is you have a computer or device, and you log in to several applications on that device with your credentials, but some of them uses cache credentials. And when you change your password, only specific application starts authenticating with the wrong password, and you start getting those failed authentications. But at the same time, the other applications on your device and your device itself can authenticate without an issue. And just because you see failed authentications coming from the same device, you start you alert as a brute force attack or attempt. But if you say if there are failed logins, but at the same time, if there are successful logins by using this logic, then you can say, okay, there cannot be a brute force attack because I can see successful authentications coming from the same place. So probably it's a cache credential issue or an application configuration issue which needs to be updated. Then you can reduce those false positives. This is what I have seen most of the time related to brute force, and it always creates false positive alerts for this reason.
Yeah, exactly.
And I think you can also use. I think we don't have event MITRE IDs in the raw events in Microsoft Defender, but what you can also do, so you can create alerts which have high false positives or high false positive rate, but you may not create incidents on your case management platform. And what you can do, you can combine these alerts together by using this logic. And since the alerts have tactic and technique information, so you can say, if I see one, let's say, initial access alert, and then one privilege escalation alert, and then one persistence alert, then create an high fidelity or high severity incident. So instead of trying to give lots of conditions in your rules to reduce false positives, just don't do that and use this operator, because let them keep firing false positives, but don't use them directly in your case management. So don't triage them directly, like especially with the low severity alerts, let's say, but combine them all together and create attack paths or execution paths. So you can just create higher fidelity alerts. And if you also look at the some incidents, Defender for Endpoint also has the same behavior or capability. So if there are certain incidents or alerts happened on the same host, it also creates high fidelity incident based on that. So for your custom detections, you can also do the same, and you can customize it. You cannot customize how the MDE works at the background, but you can do it for your custom alerts. And also you can do the same on Azure Sentinel as well with other logs. So it's like a building, creating building blocks, and then using those building blocks to create higher fidelity or severity alerts.
Cool. And would you also use this to correlate maybe commands like whoami and netuse and the recon commands, and then combine them together and then create a better alert?
Yeah, exactly. Instead of creating only on whoami, you can say whoami and this other event, or who am I, and any other comment, etc.
Cool. Anyone else got any questions?
I don't see.
No. And I want to thank you a lot, man, because it's a really interesting operator and you can use it for
Yes,
so many.
it's so powerful.
Cool.
Stop sharing.
Before I go to the event. Oh, let me share my screen again. Then on to the next part of the show. What did you do with KQL this month? What I did this month is I was playing around with the AMA agent and with in this case Fileshare auditing or file auditing. But what we wanted to do is we wanted to see when a user changed specific files in a specific folder. But the thing is, if you just use the plain old auditing or you just ingest the whole security event log, that can be quite cumbersome or high ingestion rate. Because, for instance, I have this server over here. And on this server, I enabled almost all the auditing settings. And if we go to the security event log, then you see that there are a lot of events created, and you probably don't want all of those to land in Sentinel because it can get a high ingestion rate, and it's not very useful if you're just building a data lake without the detections. So in this case, what we want to do is we want to only see, for instance, the file system events, and we only want to have certain steps. In this case, what we have over here is we have a super secret folder, and in the folder we have the tiramisu recipe. And we want to make sure that no one changes the grams or the values or everything because we want to have the same recipe every time. So what you can do from the Sentinel portal, you can create an AMA rule. And then from the AMA rule portal, so what we do is we go to Sentinel and then we go to data connectors AMA. What you can do is you can create a layered approach through your data collection. In this case, I created a data collector rule. And from the data collector rule, I assigned it to the server. And then what I did is I created these custom XPath queries. So what I've done is I created 3 of those for the 4663 event. And then what I've done is I've checked the XML for the specific components, and these values are the ones where you write to a file. You can also see in the Microsoft Tech Doc what they contain. So, and the way you create the queries is if you go to one of the items, you go to the details, And then let's make this a bit larger. In the XML view, you see over here we have event, system, and then the event ID. That's the first part, event, and then system, and then the event ID. And then we also want the event data. You have over here event data, and then you have the, in this case, the access mask, and we only collect the OX2, OX4, and OX6 because those are the write events. And then if you go to edit this specific file, you said let's make it 40 large egg yolks. And then we can go to Sentinel. Go to the 30 last hands. And I'm playing and testing around a bit, so let's give it a couple of seconds. Sort by time generated descending. Then there's the OX6. User attempted to access the file. Attempt was made to access the object, but here we have the access mask is the OX2, which means I've changed the file. And if we do a project reorder, time generated access mask, and you see over here that we only have those specific access masks, so you can be really fine-grained in how you want to approach this. And also if you want to make an exclusion for a specific account, you can, the easiest way is to do it from here, because if you go to the collection rule, then you have a limit of 20 operators. So if you look here, and we edit it, go to the collection, you have 20 expressions in each box. So you can't do a lot of filtering over here. And also if you do it from the event log, there's another field for the suppression, but within the AMA, you can only collect it. So that's what I did last month. And reorder. Access mask. And if you wanted to filter maybe for the for specific for the user account data, for instance, we do the where account type equals user. And then if we wanted to sort by time generated descending, and we can now also see over here the, where is it? Process. You can also see over here that this is the process which I used to edit the file. In this case, you can also For instance, if you want to monitor for file installation events, you could create a rule for a 11707 event, and that way you can make it really fine-grained. And also nowadays the AMA agent is in public preview at the moment for Windows 10 and Windows 11. So it's an easy way to just collect the log on and log off events, or the failure to log on, failure to log on events, and then correlate those through the network. And that way you can also create, see if someone is trying to attack or trying to test accounts or users. And you can also use the scan operator to make a several layered approach to see if someone is doing things they shouldn't. So and also so with the AMA you can filter it really nice so you don't collect too much data. So that's the AMA agent for this month. Anyone have any questions regarding the?
Yani the custom collection rules, data collection rules.
Yeah.
Are they applied to all connectors, or can you select specific connectors? Because when you install the agent on a specific machine,
Yeah.
only from that machine I want to collect some specific events, but for the rest, then I want to collect default events, for example. So
Yeah.
you do that.
So you can do you can create all the per workload. You can create a data collection rule, and then you can, so for instance, log on, log on, log off, and then we want to, for instance, do it for all the systems in my subscription. In this case, it's one active. And then you can or use the old way, so collect all events or common, minimal, or custom.
Okay.
And then in custom you can
Source section you can select. Okay.
And nowadays you can add it for the Windows 10 and 11, and also they changed the way you onboard it. Because first it was that you have to first onboard, for instance, an on-premise device in Arc, and then add the extension, and for your Azure VM add the extension. But now if you have an Azure VM, then you can also immediately onboard it with the extension. So if we go to virtual machines, and I'll just pop in a small one. So let's see, test Windows 2K22, and let's local admin. Oh. Let's just generate a random one. So the recording icon will be on the YouTube channel. If you search YouTube, look for KQLCafe, then this will be the fifth recording we'll have. You're welcome. Okay, so the VM is now deployed. So if we now go to here, create a data collection rule, security events, let's call it all security events, add resource, test lab. So now there are 2 and it already shows here. And once I starts the collection, then now in the backend, it will assign a system identity and install the extension, and it makes life a bit easier. You know. So now it will now collect all the security events from both the servers. So I guess Mike really wants to see the live demo.
I can show. I don't have so much time, like 5-10 minutes, if you like.
That's cool. Unless anyone has any other questions, I think it's really cool if you do a small demo.
Yeah, let's do. This is the okay. You can see it. I think the handpan, and most of the time it has 8 nodes in it on it. So these are the nodes, and you can have up to I think 22 nodes. And so it's not like a piano. For example, on piano you have I think around 80 nodes, if I remember correctly. But on the handpan you don't have that possibility, unfortunately, and because of that there are several different models of handpans which are called scales. So this is a specific scale, and you can have or you can buy other scales as well. And yeah, it's usually, well, to me it's kind of a meditative sound, and you can also play it like a drum. So for example, this is the lowest note. I should be, I think, yeah, this is, you can see it, right? Yeah. So you can make different sounds. what else I can play. Let me see. That's all.
Thank you. It's,
You are welcome.
nice. It's, Teams garbled the sound a bit, but it was still you can still hear the notes.
Yeah, I thought about it because of the noise cancellation.
It's you have quite a range of notes where you can play with, and
Yeah. It's definitely. I mean, although you have 8 or 10 notes on it, you can still play lots of stuff, and I find it quite amazing.
yeah, it's, cool stuff.
Thanks.
I think we're set for today, unless anyone else has any questions. Okay, then I want to thank you all for watching. And
Yeah,
then,
that's coming.
Yeah, it was awesome to have you. And now I have to create more use cases.
Yes.
Thanks all, and
Okay.
till next time.
Yeah, see you. Bye-bye.
Thank you, Mehmet.